AI can now write entire applications in minutes. But here's the real question. Do you know what dependencies your AI added? In 2026, software supply chain attacks are one of the biggest security risks, and AI generated code makes this problem even harder. Today, we'll break down why AI generated dependencies are risky, what SBOMs are and why they matter, how to review the dependencies safely, and how to use CVE databases to detect vulnerabilities early. This is mandatory knowledge for any team using AI in production. When you ask an AI to build a REST API or add authentication, it often pulls in many third-party libraries, chooses versions without security context, adds transitive dependencies you never reviewed. The risks include vulnerable libraries, abandoned or unmaintained packages, license violations, and hidden malicious packages often termed as typo squatting. Now the scary part. Developers often trust AI output more than they should. SBOM stands for Software Bill of Material. Think of it as an ingredient list for your software. An SBOM answers what dependencies are used, which versions, who maintains them, where they came from. Some of the popular SBOM formats are CycloneDX and SPDX. Many regulations and enterprise standards now require SBOM for software delivery. After AI generates code, your first security step should be generating an SBOM. Let's look at some examples. For Java, Maven, Gradle, you can use CycloneDX plugins. For Node.js, you can run npm audit along with CycloneDX. For Python, you can run pip audit and SBOM tools. This gives you visibility before the code reaches production. Once you have an SBOM, review dependencies with these questions. Is the library actively maintained? How popular is it? Depending on stars, downloads, and contributors. Is it required or can it be removed? Does it introduce risky transitive dependencies? Senior teams usually minimize dependencies, but AI tends to overadd them. Next, we scan dependencies against CVE databases. Some of the key sources are NVD, which is National Vulnerability Database, GitHub Advisory Database, and osv.dev. Now, what should we look for? We should look for critical and high severity CVEs, and if there is an exploit available, and for fixed versions. AI generated code must never bypass vulnerability scans. The best teams shift supply chain security left. That means generate SBOMs in CI, fail builds on critical CVEs, review AI-added dependencies in pull requests, and require approvals for new libraries. AI helps with speed. CI/CD provide controls. For enterprise teams, add guardrails. Some of the guardrails can be approved dependencies allow list, dependency pinnings, internal artifact repositories, AI usage policies, Copilot or AI tool rules to limit dependency sprawl. AI should assist developers and not weaken supply chain security. Let's recap. AI generated code introduces hidden dependencies. SBOMs give visibility. CVE databases expose known risks. CI/CD must enforce dependency security. Trust AI, but always verify. If your AI writes code, your security process must evolve with it. Like, subscribe, and check the descriptions for security checklists and templates. Comment below. Should AI tools be allowed to add dependencies automatically in enterprise projects?